Morning. Today we are going to do lesson 8.5, polar form of complex numbers, day 1. So we're going to start by plotting a point 2 minus 3i in the complex plane. And if you notice the complex plane, rather than having x and y, it has the real and the imaginary axis. So instead of being the x-axis, that is where we plot the real part of the number, which in this case would be 2. And the imaginary part of the number would be 3i, or in this case, negative 3i. So this is the real part, and then this one would be the imaginary part. Wow, I'm going to have to slow down and let my pen write better. So if we're going to do this, this means that we go over 2 and then down 3. 1, 2, 3. And so if we plot the complex number 2, negative 3i, it would be right down here in the fourth quadrant. To be able to find the absolute value of a complex number, we are calling z our complex number, where x is the real part and y is the imaginary part. So z equals x plus yi is a complex number. And then in order to find the absolute value of z, we are just going to take the square root of x squared plus y squared. And as you see on this triangle over here on the right, it's all coming from Pythagorean theorem. So that our absolute value of a complex number is just the distance from the origin to that point. So if I want to find the absolute value of z, if z is negative square root 3 minus 3i, I am just going to take the square root of 3 squared plus negative 3 squared. Now if I do this on my own, I usually don't even mess with this negative because it's just going to get squared out, but I didn't want you guys to think I lost it because I do have a habit of doing that. So if we square the square root of 3, we get 3, and a negative 3 squared is 9, and then 9 plus 3 would be the square root of 12. So we can simplify that, right? Because 12 simplifies into 4 and 3. The square root of 4 would be 2, and then the 3 stays on the inside. And so that would become 2 square root 3. Or if you guys want to make it a decimal, you can make it a decimal, and it would be 3.46. I wanted to illustrate that on the graph so that if I'm finding this, the square root of 3, honestly, the only way I know how to plot it is if I put it in the calculator. And so the square root of 3 comes out to be approximately 1.7 something. And so if I'm going to graph it, that means I'm going to go over almost the 2, 1.7 something, and down 3, which would be right here. And so what you guys found was this distance right here from the origin to this point, square root of 3 minus 3i. So in this case, this would be your absolute value of z. So we also have to work with the polar form of a complex number. So if we start with our rectangular form, z equals x plus yi, and we use the same substitutions that we used yesterday, right? Because instead of x, we can substitute in our cosine theta, and instead of y, we can substitute in our sine theta, right? So we're substituting those in because that's how we switch back and forth between polar and rectangular. Then, if we want to simplify it even more, we're going to factor in r out of both terms, and we get r times parentheses cosine theta plus I sine theta, which can be abbreviated even more as r cis theta. So these two are the exact same thing. This one down here is just the shorthand way of writing it. And as you guys know in math, for the most part, we usually like the shortest amount of writing. R is considered the modulus and theta is considered the argument. I really don't stress about knowing those terms. I'm just putting them out there in case somebody throws them at you. You've heard them or seen them before. So if we want to write the complex number in polar form using degrees, for me, I still always go back to triangles. So if I'm going to do this one, let's see, it tells me to go over 7 and down 5. So if I'm going to create a triangle here, I'm going over 7 and down 5. And my angle theta would be right here. So the first thing I need to do is find my radius, right? And I'm going to do that with Pythagorean theorem. R squared is equal to 7 squared plus negative 5 squared. So R squared is equal to, what is it, 49 plus 25, or let's see, R is equal to the square root of 74. And I don't think that simplifies, so I'm going to leave it just like that. So now I've got my radius for polar form. The next thing I need to find is the angle. And in this case, the easiest thing to do is to look at tangent. So I'm going to look at tangent of theta, which is opposite, negative 5, over adjacent, which is 7. And this isn't a special triangle, this isn't anything I know. So in order to find theta, I'm going to need my calculator. And I'm going to put in tangent inverse of negative 5 over 7. And I will find out that theta is negative 35.5 degrees. Now, we can leave it like that. That would be just fine. Or, if I call this theta 1, the actual theta that I really want to find and write my angle with, if I can change my pen color here, would be this angle out here, right? So in order to find that theta, I'm going to take 2 pi minus theta 1. And so if I take 360 degrees, oh, I am doing degrees, aren't I? Sorry. 360 degrees minus 35.5, I get 324.5 degrees. So we can call this one, wow, I'm going to have to sink this pen because it is not wanting me to. There we go. Let's see. Sorry. Now that I got my pen back, I can name this two different ways. We could call this the square root of 74 cis of negative 35.5 degrees. Or we could call this the square root of 74 cis 324.5 degrees. And you're right, it really doesn't matter. It only would matter if the book gave you some sort of restrictions. There's no restriction on this one, so either answer would be just as good. Now let's try doing the same thing, but we're going to do this one in terms of radians. So write the complex number in polar form using radians. First off, I'm going to draw my triangle and find my radius. So this time, x is going to the left because it's a negative square root 3. And y, my imaginary one, is going up by 1. So in order to find my radius, radius squared is equal to the square root of 1 squared plus negative square root 3 squared. So that becomes this, sorry, I put in my square root. If I already take my square root, I shouldn't be squaring it. So that would give me 1 plus 3, or in other words, the square root of 4, which is 2. Ha! If I would have paid attention earlier, I should have recognized this as my special right triangle, shouldn't I? So, because I have my 1, 2, square root 3, which means that this is 30 degrees, or pi over 6. So at this point, I wouldn't have even had to do Pythagorean theorem if I would have recognized my triangle. I just could have gone straight to being r equals 2. And I can say that 2 cis, remember that's sine and or cosine and sine, and my angle, oh, what is my angle? Let's see. All the way over here, 180 would be 6 pi over 6. But I'm not going all that way. I'm taking off the pi over 6. So my angle should be 5 pi over 6. So cis of 5 pi over 6. Now remember, just so you guys, so I make sure I'm clear, more often than not, your book uses the cis because it's the shortest abbreviation. But that is the same thing as saying 2 times cosine 5 pi over 6 plus I sine of 5 pi over 6. Right? Those two mean the exact same thing. Now we get to do the fun thing of going back the other way. This time we're going to give you the complex polar coordinates, and we're going to go back and put it in rectangular form. So in this case, we know, we're remembering that x is equal to r cosine theta. So r cosine theta. Well, in this case, my radius is given to me at 7. And I'm going to find out what the cosine of 25 degrees is, and I'm going to put this whole thing straight into my calculator, and I'm going to find out that it is 6.34. And then I'm going to do the same thing for y. Y is equal to r sine theta. So that means my radius is still 7, but this time I have the sine of 25 degrees. And so 7 times the sine of 25 degrees is 2.96. So if I'm going to write this in rectangular form, I would write 6.34 plus 2.96i. Trying to make my decimal places show up. And that's it. I've converted it to rectangular form. Try one more, because this time we're going to be in radians. So in this case, we're going to do the same thing, and we're going to say that x is equal to r cosine theta. So r is 2, and cosine of pi over 3. Well, because I know pi over 3 is a special triangle, I'm going to find out its exact measurements without using my calculator. And so let's see, pi over 3, that would be my 60. So that means I have 1, 2, square root 3, which means that cosine would be adjacent over hypotenuse, or 1/2. So I have 2 times 1/2, which is 1. And y is equal to r sine theta, or in this case, 2 sine of pi over 3. And sine at pi over 3 is opposite over hypotenuse, so that would be square root 3 over 2, which simplifies to the square root of 3. So if I'm going to write this In rectangular form, it would be 1 plus I square root of 3. And that is your grammar. The I tends to go first, not at the end. And I believe that is it for today. Good luck on your homework.